Alrighty, let's take a look at question number 10. In question 10, you're going to be looking at how to find the derivative given a graph. Basically looking at for the derivative at a point or the slope of a tangent line at a point given the graph of the function. Alright, question 10 reads, the graph of f is shown to the right if g is the function defined by g of x equals quantity 3x squared minus 1 times f of x, what is the value of g prime of 5? All right, so this graph right here is a graph of f of x. All right, so let's go ahead and do it. We want to find g prime of 5, okay? So if you're looking for a g prime of 5, it's a two-part process. Very important to know that. To find g prime of 5, you want to break it up into two parts, okay? First thing you want to do is a calculus step where you find the derivative of the function. And then secondly is the algebraic component where you evaluate your derivative at the specified input value, which is 5 in this case. Okay, so this, what we're looking for, is also known as the slope of the tangent line. Now, let's go ahead and get started with the first part. So for part 1, we're going to try and find the derivative of the function. All right, so for part 1, we want to find g prime of x. So g prime of x. All right, so g of x is given by the quantity 3x squared minus 1 times f of x. So how do you differentiate a scenario like this? Notice you have a product, right? So that should tell you what formula we're going to use. We're going to be using the product rule. Okay, so let's review what the product rule is again real quick. So if you have the product of two functions and you want to find the derivative, is v u prime plus uv prime. Alrighty, so in this particular situation, this quadratic binomial will be our u, and the function f of x will be our v. So when we apply the product rule, the derivative of this function, g prime of x, is going to be v, which is f of x u prime. If you differentiate 3x squared, you get 6x, because the derivative of 1 is just 0, right? So that's vu prime plus u, which is quantity 3x squared minus 1 times v prime, which is f prime of x. There you have it. Now we're going to find the derivative. We're done with part 1, okay? There's no cosmetics that we need to do here. So let's go ahead and attack the second part, which is the, well, this should be purely algebra, but we have an f prime of x scenario here that will require us to use calculus and algebra. So we want to evaluate the derivative that we found at the specified x value, which is 5. Okay, so what does that mean? Well, it just means we just input 5 everywhere we have x. So f of 5 times 6 times 5 plus 3 times 5 squared minus 1 times f prime of 5. There goes another slope of a tangent line again that we have to address. So let's go ahead and do this. So g prime of 5 is as follows. So f prime of 5 just means evaluate the function at 5. So f of 5 is 0, as you can see here. If your input is x on the graph, then your output is going to be 0. So f of 5 is 0. 6 times 5 is 30. Doesn't really matter because it's going to go away anyway. So this is 30 plus 5 squared is 25. 25 times 3 is 75. So we have 75 minus 1. What is this f prime of 5 here? How do we find f prime of 5? Given the graph, how do you find the derivative? Well, it's nice that we have 3 linear segments here, so we can easily determine what the derivative is. If we make use of All right, to find f prime of 5, we're going to be finding the slope of the tangent line at 5, okay? Now, since this point right here is in the interior of a straight line, this entire line is equivalent to the tangent line. So this line is the tangent line, all right? So whenever you're looking for the derivative of an interval, where the function is linear on that interval, that function represents your tan line. So all you just have to do is find the slope of the line because the slope is constant on that interval. So to find f prime of 5, we're simply going to use algebra. So to find f prime of 5, we're just going to look for two lattice points that can easily help us to evaluate the rise over run. Okay, so let's look here. I like to pick this point right here. This is a nice little lattice point. And this is another one right here. You do rise over run. So in this particular case, we're dropping 2 units. So we have a negative rise, -2, and we're running 1. Okay, so your rise over run is going to be -2 over 1. And that will represent the slope of the tangent line because the line segment because it's a line segment. All right, so plug it in here, times -2 for f prime of 5. So all that's left is just arithmetic. We're just going to PEMDAS this equation and get the final answer. All right, so for simplify, we're going to have g prime of 5 equals 0 plus 74 times -2. And when you multiply 74 by -2, you get -148 as the value of g prime of 5. Ladies and gentlemen, the answer to question number 10 is option letter B. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP Calculus AB exam, do give us a like or a thumbs up. Do not forget to subscribe to our channel for updates to other great math tutorials such as this. If you have any questions or comments, just put it in the comment section below as indicated earlier. Tons of support resources can be found at our website, mathgotserved.com, under AP Calc, and also in the links in the description below. Thanks again for watching and have a wonderful day. Goodbye.